Today we're going to look at a way of integrating a particular type of differential equation. Let's have a look at an example. Here is a differential equation which doesn't look all that nice. We certainly can't separate the variables in the way that we have been doing. It's not an exact equation. So what do we do with it? Well, let's play a little trick on it. Let's multiply through by x to the power 4. That will give us x to the power 4 dy by dx plus 4x cubed y is 2x e to the x squared. Now have a look at the left-hand side. You should be able to see something about the left-hand side. You should be able to see that this is an exact equation, and the left-hand side is the derivative of x to the 4 times y. Let's just write that down so that we can see it. If I differentiate x to the 4 times y, it's a product. X to the 4 differentiate y plus y differentiate x to the 4. Yes. So that little multiplier, that magic multiplier, has transformed this into an exact equation. That is still 2x e to the x squared. Let's integrate each side now. We get that x to the 4y is the integral of 2x e to the x squared, which fortunately is rather nice. That is just e to the x squared. Differentiate it, e to the x squared times 2x. Yes, we're right. And I didn't forget the plus c. Now let's divide through by x to the 4, and we get y is e to the x squared plus c, all divided by x to the 4. So the question now is, how can we find the magic multiplier? We have to start with an equation which has dy by dx all on its own, a function of x times y, and a function of x. So we shall now look into how we can find this magic multiplier. Well, to do this, let's look at a general equation. I said just now we had to have dy by dx on its own. Whatever is multiplying y has to be a function of x. There's no y at all. And the other side has to have no y. So p and q must both be functions of x. Well, let's suppose that r, which is a function of x, is the magic multiplier. Then, multiplying through by r, we have that r dy by dx plus r p y is equal to rq. Now we want this to be an exact equation. We want the left-hand side to be the derivative of a product. And looking at the first term, r dy by dx, if I want this to be the derivative of a product, I must be starting with d by dx of ry. So let's have a look at that. D by dx of ry. And that must be equal to the left-hand side, which is r dy by dx plus rpy. Well, if we differentiate ry, differentiating y, we get r dy by dx plus y, differentiate r, we get dr by dx. And that has to be equal to r dy by dx plus rpy. Well, the r dy by dx disappears. I'm left with y dr by dx is equal to rpy. Can we do two things at once? Divide by y and divide by r, perhaps three things at once, and multiply by dx. And integrate. Well, we can integrate 1 over r, that's log r. And then we know that r is equal to e to the integral p dx. R is called the integrating factor. Let's look at this example. The first thing to remember is that we must have dy by dx on its own. So if we divide everywhere through by x, we get dy by dx is equal to, not equal to, plus 2 over x times y is equal to 1 over x. Now we have the equation in the right form. We've got dy by dx on its own, we have a function of x times y, and we have another function of x. My integrating factor, it's quite sufficient to write if, is e to the integral p dx. P is whatever's multiplying y. So that is e to the integral 2 over x dx. That is e to the 2 log x, and that is equal to e to the log x squared, which is just x squared. We only need to find one integrating factor, so we don't actually worry about a plus c when we integrate. That simply would say there are lots and lots of different integrating factors. Why don't we just choose the easy one when c is naught? So my integrating factor is x squared. Let's multiply through by x squared. We will get x squared dy by dx plus 2xy is x. If this has worked, the left-hand side ought to be the derivative of x squared y. At this point, you should always stop and check. Differentiate it and see if it works. X squared, differentiate y, yes. Plus y, differentiate x squared, yes. That equals x. Integrating both sides, we get x squared y is equal to the integral of x dx, which is x squared over 2 plus c. Divide both sides by x squared, and you will get 1 over 2 plus c x to the power minus 2. This is quite a simple procedure. The only possible real difficulty comes in what happens over here after you've multiplied by your integrating factor. With any luck, you won't have something which is difficult to integrate, but you might end up with more of a problem there. The other side is relatively automatic.